Hey Trig, welcome back. This is C Squared Mathematics, and what we are going to be doing today is just a Desmos activity. No bell work. I'm actually going to skip out the bell work on this. I'm confident that you guys can still do it though. Just review the homework, review your notes, and then you guys got it. We're going to go straight to the homework quiz, then the burning daylight Desmos activity. Homework quiz, 5 questions, 25 minutes, open notes. Please review your answers. This one is notoriously not difficult, but notoriously frustrates, I guess, students because it's so finicky with how you type in the answers. You have to type in equations and everything. Some students forget a negative, a pi, just the whole function sign, but they got everything else. So I can understand that. So please send your partial credit requests if needed or if necessary. Okay? Go ahead and start that. You can pause the video. Make sure you do that. Again, I apologize for the bell work. I'm not feeling it. I'm very bogged down with work right now, so I'm not going to go through the bell work. I apologize. But as soon as you're done with that, go ahead and get started on the Desmos activity. I'm only going to go through a couple of slides with you. It's actually a very, very short Desmos activity. What we're going to be doing is basically just looking at sine and cosine graphs, but specifically the application of sine and cosine graphs in sunlight, essentially daylight, and how to model these graphs using two cities, totally different cities, Fairbanks and then Miami. Fairbanks and Miami. So here you go. Go on to student.desmos.com, type it in, let's get started. So we're going to be looking at Fairbanks, Alaska, which is completely different. I mean, just look at the total difference. I mean, it's just totally different on the sides of the United States. So just think, which city do you think has more total daylight during the year? Think about it. Which city do you think has more daylight during the year? I am going to say Fairbanks, not because I know what the answer is, but because I think when I'm going through it, I mean, if you have 30 days of night in one city in Alaska, is it not true that you would therefore have 30 days of light instead of night in Alaska? I mean, the 30 days of night is not just a movie. I mean, it's an actual thing. You have 30 days of darkness in Alaska in one particular city. And so I'm thinking maybe we'll have 30 days of sunlight there. So whatever you think, it doesn't really matter. Just think. Try not to look it up either. Just it doesn't matter. Just think. Okay, I think there's about 30 days of light in Alaska, or maybe because Miami's like so summery and it's right near the Bahamas. It's fantastic. Like maybe let's just go for it. Okay. The graph here shows the number of hours of daylight on the first day of each month, so 2015 and 2016. So which graph do you think represents Miami? Which graph do you think represents Miami? Okay, I'm just going to say orange. It doesn't really matter. I can say whatever I want to say there and then move on. And then boom, the orange graph. Awesome. I'm great. So I guess it was the orange graph. So the orange graph represents the hours of daylight in Miami. So now here's the thing. Here's the hard part. Okay. The hard part is trying to figure out exactly what we need to do this function. Okay. Now I just want you to guess. You don't need to get too precise, but how can I actually create a function here? First off, I actually noticed that this is probably cosine because of this. Okay, so I noticed that's probably cosine here. I also noticed that's not flipped and it's raised and it's sort of shifted. Okay, so the first thing I want to do is kind of gather like, okay, what's my amplitude? Well, my midline is this. Okay, that's my midline, which means, wow, that looks like junk. I'm going to erase all this. Sorry. My midline is this. And this is my actual function, probably cosine. And so my midline, that's probably like what, 10? No, 12? So that's like 12, right? So that means my amplitude is probably roughly like 12, okay? Roughly 12. And what's my period? My period is 2 pi over b. We don't even know our b, but we can figure out whether or not, like, if I know my period, then I can figure out what b is. So what's the length of this? So right here, maybe let's just say that's like 7, okay? And then right here, let's just say that's like it's close to that, so that's maybe like 20. So maybe this is like 18 or something, okay, or 19. Let's just say 19. So how do I figure out that? Well, I subtract those two, so that means my period would be what? Subtract that, so 12 again. So now, in order to find my b, because I need the b in order to find the equation, I can do 12 equals 2 pi all over b. Then times b, that goes poofy, divide by 12. So now b equals 2 pi all over 12, which reduces down to pi all over 6. So that means roughly, my b would probably be pi all over 6. So what do I have so far? So far what I have is y equals, I got 12 cosine, and then my b value is just pi divided by 6, and then x. Wow, why do I have an I there? Pi divided by 6, and then x. Okay? And this is sort of what I have. Now I need to shift it. Okay, that's what I need to do. You see right here, they'll actually kind of tell you what you're putting in. So really, right now, guys, it's just trial and error. I need to shift it up somehow, some way. So I think this is shifted up like, let's find out. This is shifted up like 12 units, so I do plus 12. But then I notice, oh shoot, okay, so my amplitude was too big, okay? My amplitude was too big, so now I need, okay, how do I make this shorter? So if it goes from here to here, and I just need this a little bit, then that's probably like what, 2? So let's try 2. So that means you'll go over here and delete that, and like, okay, that's a little bit better. And then how do I kind of shift it over? Well, I need a shift. So let's just say I need to shift it to the right. Maybe say 5, or maybe say 7, or 9. We're getting closer, maybe 10. That's pretty good, right? That's pretty good. So whatever, try to get it as close as possible. Try to get it as close as possible to what you think you can get it, okay? But that's how you sort of kind of maneuver how to write a model using just the graph, So after you do that, what you're going to be doing is doing the exact same thing for this model. I'm not going to go through that one. I'll leave that one to you. You're going to compare the graphs. Of course, they don't have an equation for me, but you're going to compare the graphs, kind of see which one is best. You're going to go through the hours and try to find out how many hours of daylight there are in Miami and Fairbanks by plugging stuff into your equation. And then you're just going to continue going reveal and show the actual answer and so forth. They actually give you a different city right here, Barrow, Alaska. Okay? Sweet. So please do that. Go ahead and sign in if you haven't yet to sign in, student.desmos.com. I really like this activity. It really just gives us a break from the monotony of just the notes, and just kind of allows us to basically apply the mathematics. Okay, so again, please go to student.desmos.com, type in the code, and then start. Okay, and that's all I have. Don't forget about the trig functions quiz. If you can't somehow get logged into Burning Daylight Desmos activity, you can go ahead and click on this, and it'll take you right there. Okay, if you don't have anything else from me, just continue working. But if you do have questions for me, make sure you are emailing me, showing up to the Google Meets, and so forth. I'll see you guys later. This is C Squared Mathematics. Make good choices.